In this video, I want to work through a problem relating to the formal definition of the limit. But before we work through this problem, let's just talk a little bit about this definition, this formal definition of the limit. So let me scroll down here. I have the definition here. So what the definition says is that for every epsilon greater than 0, so epsilon is just some number, you can pick any one you want. For every epsilon greater than 0, there exists a corresponding delta greater than 0. So the greater than 0 just means they're both positive numbers. All right, so for every positive epsilon, there exists some positive corresponding positive number, we'll call it delta, such that the distance between the y values and the limit value. So that's what's going on here. These are the y values of the function. That's the f of x, and L is the limit value. Right? Is less than epsilon. So this is the absolute value function, also called the distance function. Right? So epsilon has to do with the y values. So epsilon is in the y direction. Whenever the distance between an x value and c is less than delta. So that c is so when we have the limit as x approaches c of f of x equals L. So there's the c and the L. The c is the specific constant that the x values are approaching, and the L is the value, the y value, the corresponding y values are approaching. Now, we talk about limits informally a lot and say as the x values get really, really close to c, the y values get really, really close to L. That's what this statement is saying, this whole limit statement. As the x values get really close to c, the y values get really close to L. Well, saying get really close to is not really a technical, mathematical way of describing something. Okay, so let me get rid of this red. Okay, so let's look at this visually. Let's say, I don't know, I have some generic function. Let's just make it look something like this. So here's our f of x, okay? And let's say down here is our c. And so there's this point on the graph here. And so this would be f of c. So what we're saying here, and so it looks like, and I'm using a continuous function just for simplicity's sake, but the function doesn't have to be continuous necessarily. What this is saying is, so there's L. What this is saying is, for every epsilon greater than 0, and so what this is saying, f of x minus L absolute value, the distance between y values and L is less than epsilon, or all y values within a distance of epsilon. So this would be L plus epsilon and L minus epsilon. All right, so we have this like epsilon band around the limit value. So these are all y values that are less than a distance of epsilon away from L. Y equals L. Okay, and so what this is saying is, so I could have drawn L plus epsilon way up here. I could have drawn it down here. It's arbitrary. Epsilon could be anything. I mean, we really only care about what's going on when delta and epsilon are very small numbers, but they could be anything. So what this is saying, once you pick epsilon, there exists a corresponding delta. Let's do this. Let's do this. So once I chose epsilon first, and so epsilon is, let me use green here. Epsilon is this distance. That distance is this number epsilon. So once I pick that distance epsilon, I go back to the function. So I sort of go backwards from the y values back to the x values, or from the function values back to the x values. And so this right here would be delta. Well, whichever one of these is larger would be delta, one of these two. So what this is saying is that as long as you pick x values within this range, within a distance of delta or less, from x equals c, these will give you y values that are at least within epsilon of the limit value. Now this is not the type of topic that you see it once and it clicks. This is actually it's one of the first topics we cover in a calculus course. It's also one of the most confusing throughout the entire semester. My students always, for 20 years, my students have been saying, at the end of calculus, when I say, what were the most difficult parts? There's just a short list of maybe 2 or 3 topics, and this is always on that list. So you might need to watch this video, maybe watch a couple other videos, read the book, read the notes. Eventually it will click, but this is what's going on. So what we're doing is, let me scroll up to this problem. So in this problem, we are picking, or not picking, we're given a value of epsilon. So specifically, if epsilon is 0.005, what does delta have to be? So if I go back down to this little graph I made, so this would be L plus 0.005 and L minus 0.005. Okay, so that's enough background for now. So now let's look at this problem. What we want is the absolute value of f of x minus L is less than 0.005. And then we got to do some work and eventually get down to the absolute value of x minus c is less than some number. So as we sort of work with the left-hand side and make the left-hand side, transform the left-hand side from this to this number is going to change. And this number is going to change when the left side looks like what it's supposed to look like. Whatever number is on the right side, that's going to be your delta, the corresponding delta that works with the epsilon value that we start with. Okay, so let's erase this. So what is L? First of all, what is L in this case? Oh, we could use direct substitution here. We could plug in the 6 for x. So this limit looks like it's 6 minus 6 over 3, or 6 minus 2, which is 4. So L equals 4. Okay, so we have absolute value of f of x. So here's our f of x. That's the 6 minus x over 3. And then minus L, which is the limit, which is 4, is less than 0.005. Okay, 6 minus 4 is a 2. Okay, so that becomes 2 minus x over 3. Absolute value is less than 0.005. Now we know we want to end up with the absolute value of x minus 6 is less than something, because here's our x is approaching 6, so our value for c is 6. So when we're starting this problem, epsilon is given 0.005, c is 6, L is 4, and delta is question mark. So this is basically what we're trying to do, is figure out for this value of epsilon, c, and L, what is the value for delta? Okay, so we know we want x minus c or x minus 6 on the left-hand side. Okay, so we want an x here, not an x over 3. So let's get rid of the over 3. So what we could do is we could maybe multiply both sides of this equation by 3. Okay, so if we multiply through the 3, that'll give us a absolute value 6 minus x is less than 0.015. Okay, so this is what I meant when this number on the right will change along the way as we're working with the left-hand side. And so let me erase this for now. And let me go over here to the side and just recall property of absolute value. The absolute value of a minus b is the same as the absolute value of b minus a because the absolute value makes both of them positive. So we could just switch the order here. 6 minus x and x minus 6 are different, but with the absolute values, they're the same. So 6 minus x is the same as absolute value. X minus 6 is less than 0.015. And that is our absolute value. X minus c is less than delta. Okay, so here is our, in this particular case, here is our value for delta. Delta, so its final answer here, delta equals 0.015. And let's use the rainbow. Okay, and so that's basically it. So we know, before we start the problem, we know where we're starting, and we know where we need to end up. What we need to do is just all that stuff in the middle and all that stuff in black. That's what you have to do in terms of solving this problem. Okay, that about does it for this one. I hope this was helpful.